So today our goal is to calculate the wind force or wind load acting on our truss. So for that, IS code is devoted entire code for that. The code number is IS 873 part 3. As you know that IS 875 had 5 parts. Part 1 dead loads, part 2 imposed load, part 3 wind load, part 4 snow loads, and part 5 load combinations. But due to the erratic behavior of wind in the Indian coastal regions, so IS code has been revised recently, and that is revised in 2015. So henceforth, please follow the IS code IS 875 2015, not the previous of 2000, I think 87 or 3. Okay, so this code has many changes than the previous code. That's why you have to follow this code. Now I'm going to the code first, and then I'll do the practical numericals for this. So code name is design loads other than earthquake for building and structure, code of practice. So what is the code for earthquake? That is 1893 part 1. Okay, that means if I tell you to design a building or any structure, we need these things. That means for IS 875 part 1 for dead loads, IS 875 part 2 for imposed loads, IS 875 for part 3 for wind load, IS 875 part 4 for snow loads, and part 5 for load combinations. And when you get these loads, you have to consider IS 1893 for seismic or earthquake loads. See, here also some definitions are there. I'll quickly go through the most important one, which can be used in this case. So angle of attack, an angle between the direction of wind and the reference axis of the structure. Then breadth, it means the horizontal dimension of the building measured normal to the direction of wind. Okay, that means across the wind, the width, that is your breadth. Breadth and depth are the dimension measured in relation to the direction of wind, whereas length and width are the dimension related to the plan. That means, for example, if this is a plan of building and if wind is flowing in this direction, then as per this, your length and width will remain this. This will be length and this will be W, irrespective of your wind direction. But your breadth and depth will be depends on your wind direction. It means horizontal dimension of the building measured normal to the direction of the wind. So if wind is flowing this direction, then this will be your width and this will be your depth, the dimension in the direction of wind. But if in any means wind direction is this way, then this will be your width and this will be your depth. So breadth and depth will be varied based on your wind direction. Perpendicular to the wind direction will be your breadth, and parallel to the wind direction will be your depth. Are you not telling anything? Length and breadth as per your structure. L and W is your planned dimension of the structure. Okay, it will be fixed irrespective of the wind direction. But depth and breadth is the same thing, but it will be interchanged or it will be changed according to your direction of wind. Okay. For example, when this is the wind direction, that horizontal one, then W will be your breadth and L will be your depth. But when this vertical will be your wind direction, then L will be your breadth and W will be your depth. Understood? Okay, then developed height. It is the height of upward penetration of the velocity profile in a new terrain. At large fetch lengths such as penetration reaches the gradient height, above which the wind speed may be taken to be constant. At lesser fetch lengths, a velocity profile of a smaller height, but similar to that of the full developed profile of that terrain category has to be taken. With additional and provisional that the velocity at top of this shorter profile equal to that of the unpenetrated area velocity profile test. Okay. So this will count for the long height one, not for a small case. This is very important. Effective frontal area. The projected area of the structure normal to the wind direction, that is your effective frontal area. That means here height will come into picture. So in this case, if this is your things, and then if this is your wind one, And these heights should be your frontal height. Normal to that. That means which the area which is obstructing your wind, that will be your effective frontal area. Then element surface area. The area of surface over which the pressure coefficient is taken to be constant. Okay, in our case, that influence area, as I shown in that case, the live load, dead load. So that influence area will be taken as the surface area for our case. Now force coefficient, a non-dimensional coefficient such that the total wind force on a body is the product of the force coefficient, the dynamic pressure of the incident design wind speed, and the reference area over which the force is required. When the force is in the direction of the incident wind, the non-dimensional coefficient will be called the drag coefficient. And when the force is perpendicular to the direction of the incident wind, the non-dimensional coefficient is told as a lift. So what is lift and what is drag? Again, along the direction is drag, and across the direction will be the lift. Okay. Now gust, a positive or negative departure of wind speed from its mean value, lasting for not more than say 2 minutes over a specified interval of time. So gust is the above the average wind pressure. For example, that I think you feel there's suddenly some extra wind when during cyclone or some little bit of heavy wind, you may have experienced that normal wind flow is there. So suddenly you're getting some extra thrust. So that comes as a gust. Understood? Feel it, no? When you are in open space, normally some wind is flowing that you are feeling, but sometimes some extra force you are feeling. That is your gust. Okay. A peak gust speed is the wind speed associated with the maximum amplitude. Obviously, what is the maximum value of that extra thrust? That will be your peak thrust. Now, fetch length. It is a distance measured along the wind from a boundary at which a change in the type of terrain occurs. When the changes in terrain types of encounter, such as the boundary of a town or city or forest, the wind profile changes in character, but such changes are gradual and start at ground level, spreading or penetrating towards with increasing phase length. That means when the ground surface and ground profile started changing, from that you have to find out the phase length along the wind. They told us that when there are terrain changes are there, that topographical changes are there, like city profile change, forest area to land area. So there the wind speed also will change in a defined way. That is called your phase length. From that to the location of your building or structure will be the phase length. Understood? Because the wind speed and wind profile depends on your terrain profile. Na? In the inside the forest, there will be some one type of profile. Outside the forest, it will be different. In open playground or open air, open land, there will be another type. In city inside the city with tall buildings, another one, small buildings, another ones. So depending upon the density of structures and other thing obstructions, the wind profiles will be different. That's why you need to find out this phase length. From that change started, where the standard charges. Okay, then gradient height. It is the height above the mean ground level at which the gradient wind blows as a result of balance among pressure and gradient force. Okay, for the purpose of this code, the gradient height is taken as the height above the mean ground level, above which the variation of wind speed and with height need not be considered. Okay. Okay, now what is high-rise building? Very commonly you are asking about these things, so be clear about this. High-rise building or tall building. A building with a height more than or equal to 50 meters or having a height to smaller dimensions, more than 6 are called high-rise or tall building. 60 or more than 60 stories, you can tell as a tall building. Okay. Also, notwithstanding 50 meters, if your height is more than 6 times of the smart dimensions. So for suppose you are making a 6-story or 8-story building also. Okay, so 8-story building, your height will be around 25 meters. Okay, so 25 by 6 means it is 4. So if the width if the width of the building is 4 meters and you are building a 8-story height building, then that also will be termed as tall building. Are you getting me? Irrespective of the width or length, if the height of the total building is more than 50 meters, it will be a high-rise or tall building. There is no question of that. Apart from that, a shorter height also can be termed as tall building if the height of the building is more than 6 times of the width or shorter dimensions. That's I told. You have a 4 meter width of the building, 4 meter, and you have built a 8-story building. The 8-story building is around 25 meters of height and 4 meters. So 25 4 is more than 6. Then also it will be termed as your tall building. Understood? Now low-rise building, the building having its height less than 20 meters. That means around 6-story. Okay. So for around 6-story buildings, you can take it as a low-rise building. Now mean ground level. So it's clear what is tall building, what is a short building or low-rise building. So pressure coefficient, that's all we will find out. So we'll go detail into what just I'm reading now. It is the ratio of the difference between the pressure acting at a point on the surface and the static pressure of the incident wind to be design wind pressure, where the static and design wind pressure are determined at the height of the point considered after taking into account the geographical location, terrain conditions, and shielding effect. The pressure coefficient also equals to 1 minus Bp by Vz square, where Bp is the actual wind speed at any point on the structure at a height corresponding to that of Vz. Vz is the basic wind speed at any location that is given in this IS code. The positive sign of the pressure coefficient indicates pressure acting towards the surface, and negative sign indicates pressure acting away from the surface. Okay. So we have two types of pressures. One is the external pressure acting downward, and other is the lifting pressure which is coming, that is outside to inside one pressure, one is the inside to outside. So that difference is your pressure coefficient. Very useful one that we have to calculate on our structure also. Now, return period. It is the number of years reciprocal to which gives the probability of extreme wind exceeding. So return period, all of you know from the water access part, the same thing, same definitions. Now the pressure coefficient, you have one term, shielding effect. The shielding effect or shielding refers to the condition where wind has to pass along some structure or structural element located on the upstream wind side before meeting the structure or structural element under consideration. A factor called shielding factor is used to account for such effects in estimating the force, or that means some other small structures are there before long size accounts. Small or any structures coming before the actual structure where you are finding the wind force. Okay, so definitely the front side structure will reduce some effect on that. That's what it's called a shielding effect. Understood? It's the physical meaning of shielding only. Now suction. It means pressure less than the atmospheric pressure and is taken to act away from the surface. And lifting on a suction means it is going up. That's why it is less than the atmospheric pressure. Solidity ratio, it is equal to the effective area, that is projected area of all the individual elements of a frame normal to the wind direction divided by the area enclosed by the boundary of the frame normal to the wind direction. So solidity ratio is to be calculated for individual frames, that is individual small portion to the whole portion. That is your solidity ratio. Then terrain category, it means the characteristics of the terrain surface irregularities of an area which arise from natural or constructed features. The categories are normal in later on details are there. Topography, the nature of the earth's surface as influenced by the hill and valley configurations. Then velocity profile, the variation of the horizontal component of atmospheric wind speed at different heights above the mean ground level is termed as velocity profile. Okay. So these are the nature of wind in the atmosphere. So in general, wind speed in the atmospheric boundary layers increases with height from 0 at ground level to maximum at height called gradient height. Okay. So as you experienced already, that as you're going up, you are experiencing wind more. For example, a 10-story building. where you are in the second story or third story, you will not feel that much of wind. But if you go to 9th story or 10th story or roof, you will feel the huge wind expression. Hello? You explain that or
Yes.
not?
Yes.
Basically, I have a personal experience on that. When I'm younger than you also, I was working in Haldia Petrochemical. So in petrochemical, there are long, tall towers, distillation towers are there. Okay. So as you know, I'm working as a structural checker at that time. So I have to check all the nut and bolts and welding of every platform and every connection. Okay. So for that purpose, that there is some platforms of gratings and railing and bracket connections that there. Na? So to check that one, I climb to up to that top of that tower. That is a 100-meter tower. So as I'm climbing up, almost near to top, I am not able to stand properly because of the heavy wind, and the tower is literally swinging. At the top of the tower, that is slender, very slender, diameter maybe a maximum 3 meter and 100-meter tall. Understood? So it is literally swinging at the top of the tower. When I reach the top to check the top platform, I have to. Well, I cannot stand there. I have to sit on my knees and then they check all these things. It's so much of swinging. So as you go up, your wind velocity will be, or wind feeling will be more. Same thing is written here also. There is usually slight change in direction, but that is ignored in the standard. The variation with height depends primarily on the terrain conditions. The terrain condition, different conditions that will come in the next following sections. However, the wind speed at any height never remained constant, and it has been found convenient to resolve its instantaneous magnitude into an average or mean value and a fluctuating component around its average value. The average value depends on the average time employed in analyzing the meteorological data, and this averaging time varies from few seconds to several minutes. The magnitude of fluctuating components of wind speed, which is called gust, depends on the averaging time. In general, smaller the averaging interval, more is the magnitude of the gust speed. Obviously, instantaneous impact is more for the small time period. Now, basic wind speed. So in figure 1, that this wind, this is figure 1. Okay. So basic wind speed in meter based on 50 years return period. So from India, all over India, you can find the wind speed of any location from this map. So basic wind speed is applicable to a 10-meter height above mean ground level for different zones of the country. Okay. So when your structure is less than 10-meter height, you have to take the value for 10 meter. Okay. The basic wind speed is based on peak gust velocity averaged over a short time interval of 3 seconds only. That means you have taken very high gust speed. Because here, smaller the average interval, more is the magnitude of the gust speed. So 3 seconds is very small, so obviously you are taking very high value of gust speed while averaging the wind speed. And corresponding to mean heights above ground level in an open terrain. Category 2, that also will come later. Basic wind speeds presented in figure 1 have been worked out for a 50-year return period. Basic wind speed for some important cities also given in Annexure A. So this is your basic wind speed you can find out from this map. So there are 5 or 6 categories, 1, 2, 3, 4, 5, 6. So 6 basic wind speeds are mentioned in this figure, India map. So magenta one is the maximum of 55. So this is given in Mizoram, Tripura, some lower part of Assam and Manipur, and north side of your Leh Ladakh. Okay. So I think that means that Kargil part also part comes under this very heavy wind speed, 55 meters per second. So apart from these zones, there is no other place are this much of high wind speed. And apart from Darbhanga is there. I don't know, Darbhanga has some peculiar open terrain. So that also you'll find when individual city-wise speed was given, you'll find Darbhanga also having 55 meters per second. Okay, then comes your 50. So entire coastal region, East Coast is 50 meters per second, like Kolkata, Bhubaneswar, Visakhapatnam, Chennai, Vijayawada, everything comes under 50 meters per second. And also your coastal area of Gujarat, Kachran, will also part of 50 meters per second. Then comes here 47 meter per second. That is some part of your Madhya Pradesh, Rajasthan, some part of Gujarat, your top portion of the Bihar, entire almost top portion of the West Bengal. A very small part of the Odisha also comes under this 47 meter per second. Then 44, the Dakshinat, these are Warangal, Hyderabad, Sambalpur, Nagpur, all these are coming under your this 44. In all these plateau areas, is only 39. Almost all the Central India part is under 39 meter per second. Then last is 39, 33. This is a totally barren area because here Western Ghat Parbat is there, here Eastern Ghat Parbat is there, in between areas are there. So this is in both sides is protected from wind. That's why here wind speed is so low. Okay. So here they have picked the point from that map and they've given you for any reference. Okay. So as I told you that Darbhanga will be at 55, you see. Yeah. I don't know Darbhanga, what is there in Darbhanga. If anyone from this region, they can tell us. Some air pocket is there maybe somehow due to some surroundings, some strong air pockets are developed there. That's why Darbhanga has 55 meter per second among the prominent city. Other than this, I think no one has 55 as the wind speed. Then the entire coastal region, Guwahati, all these are coming under 50. See Cuttack, Bhubaneswar, then your Chennai, Vijayawada, Visakhapatnam, Berhampur, all eastern coastal Chennai also comes under 50. Even Bhuj. Okay. So this is the first step of your wind load calculations. Okay. If you are residing at important cities, you have to find the basic wind speed from this annexed array. And if your wind speed is not mentioned here, then you have to go to figure 1 to find out the basic wind speed as per the column. So you have to use annexure 1 to find out the basic wind speed, that is also called VZ. Now after basic wind speed, sorry, VB is your basic wind speed, VB. VB is your basic wind speed. VZ is your design wind speed. Okay. So from this basic wind speed, you have to consider some other parameters to find out the design wind speed. The basic wind speed VB for any site shall be obtained from figure 1 and shall be modified to include the following effects to get design wind speed. Okay, VZ at any height Z from the chosen structure for the risk structure. So what are the parameters? Risk level, terrain roughness and height of structure, local topography, and importance factor for cyclonic region. So here K1, K2, K3, K4 are there. K1 is for risk level, K2 are for terrain roughness and height of structures, K3 from the local topography, and K4 from importance factor for the cyclonic region. Okay, now how to get this? VB you already got from the annexure A or figure 1, you can get the VB if you know the location of the structure. Now how to calculate K1, K2, K3 and K4? So K1 is the probability factor or risk factor. It is given in 6.3.1. K2 is your terrain roughness and height of structure factors given in 6.3.2. K3 is the topography factor given in 6.3.3. And K4 is the importance factor for the cyclonic region given in 6.3.4. Okay. Now we have to know how to find out these values of K1, K2, K3, K4 from this code. Note, wind speed may be taken as constant up to a height of 10 meters. However, pressures from building less than 10 meter height may be reduced by 20% for evaluating stability and height of the framing. Okay. Now coming to your K1, risk coefficient factor K1. Figure 1 gives basic wind speed for terrain category 2 as applicable at 10 meters above ground level based on 50 years wind return period. The suggested life period to be assumed in design and the corresponding K1 factors for different class of structure for the purpose of the design are given in table 1. The design of buildings, the structures and the regional basic wind speed having a mean return period of 50 years shall be used except specified in the table 1. Okay. Now this depends on the your structure life. Okay. For temporary structures, you can take the more risk. That's why the value can be less than 1. Again, my same concept of factor of safety will be applicable here. When there is more uncertainty and more safety is required, your factor of safety will be more, and when less safety or less uncertainty are there, then you can take even less than 1 also. Less than 1 means you are taking more risk. So this is your table 1. See dimension, type of structure. Type of structure and mean probable time period and basic factor of things. See, all general building and structure for 50, all are 1. See, everything is 1 for all general building and structure. Now, temporary sheds, structures such as those used during construction operations, for example, formwork and false work, structure during construction stages, and boundary walls. For that, you can reduce the risk factor. So see, for lowest one, it is 0.82. For 55, it is 0.67. So more is the wind speed, less is the value of the factor. That means more is you're taking. Okay. That means if you are going to prepare a temporary shed, if you are going to prepare a temporary shed at Darbhanga, then your VB will be multiplied by 0.67. That means wind speed are drastically reduced. Whereas if you are going it for Nilgiri or in nearby some Kodaikanal or something, then you will take only 0.82. Okay. Buildings and structures representing a low degree of hazard to life and property in the event of failure, such as isolated towers in urban areas, firm buildings other than residential buildings. In that case, you can take 25 years return period and you can take the value of this. Here also the values are less than 1. Okay. But important structures and buildings such as hospital, communication building, communication building, then power plant structures, the most important things. Even for bridges also, you have to take these 3, all values are more than 1. Understood that because you need more safety for this. Where less safety is required, you can take less than 1. And whereas more safety is required, you have to take more than 1. And for normal structure, it is 1. Okay. So for our structures, we will take 1. The our 1 is the regular set. Okay. Not temporary structure, not any important structures. Okay. So if you have to see as you are getting our structure for more number of years, our factor of safety also going on increasing. And in our case, you can take this third one also, for your industrial warehouse where you are going to store this paddy, all these things, we can consider for the third case also, isn't it? Provided if it is not within the city. So normally in the godown, we are not going to stay. So in that purpose, there is no life hazard or risk. That's why you can take third also. Okay. Suppose you are going for your farmhouse or something. In that case, you can easily make it third one. But normally you can take for first one. Is your choice. If you want to take more safety, then you can take the first one. If you want to take some risk, then you can go for the third one. Okay. So K1 is any doubt about that for K1? See, if you're going for any building, definitely you have to take the number 1. But for shed, either number 1 or number 3. And depending upon your basic wind speed, BB. Okay, now most important part is your terrain factor. This is required for everything. Terrain and height factor, both are there for K2. First is the terrain. Selection of terrain categories shall be made with due regard to the effect of obstructions which constitute the ground surface roughness. The terrain category used in the design of a structure may vary depending on the direction of wind under construction. Wherever sufficient meteorological information is available about the nature of wind direction, the orientation of any building or structure may be suitably planned. Terrain in which a specific structure stands shall be assessed as being one of the following terrain categories. So for your information, your basic wind speed given in figure 1 or annexure A are considering category 2. Okay. Now category 1, exposed open terrain with few or no obstructions and in which the average average height of any object surrounding the structure is less than 1.5 meter. The equivalent aerodynamic roughness height Z0 for this terrain is 0.002 meter. Typically, this category represents open sea coast, flat plains without trees. A non-dimensional coefficient that the total wind force on a body is a product of the force coefficient, the dynamic pressure of the incident design wind speed, and the reference area which the force is required. That is the total wind force. Wind force means your dynamic pressure of the incident design wind speed, then your reference area and the force coefficient. Understood? And that force coefficient is drag coefficient or lift coefficient. If the force we are taking around the force direction, wind direction, that will be the drag coefficient, and across the wind force, wind direction will be the lift coefficient. Now come to your terrain category 2. Open terrain with well scattered obstructions having heights generally between 1.5 meter to 10 meter. The equivalent roughness height Z02 for this terrain is 0.02 meter. This is the criteria for measurement of regional basic wind speeds and represents airfields, open parklands, undeveloped, sparsely built up outskirts of town and suburbs. Open land adjacent to a sea coast may also be classified as category 2 due to roughness of large sea waves at high winds. So for this category, any idea, any example? In my case, I can say it's typical village of our any Indian village. Isn't it? You see, there are only 1-story or 2-story buildings are there, na? So 1-story means 3 meter, 2-story means around 6 meter. And that also with wall, mud wall or brick walls with the tin shed. Okay. So that is perfectly comes under your category 2. Comes to your category 3. Terrain with numerous closely spaced obstructions having the size of buildings, structures up to 10 meter in height, with or without a few isolated tall structures. The equivalent geographic special site for this is 0.2 meter. These category represent well-wooded areas and shrubs, towns and industrial areas full of forestry developed. It is likely that the next higher category than this will not exist in most present situations. Okay, so our party area is, I think, the best example of category 3, isn't it? So if you are going to build one, go down in Kit campus, then you have to take category 3. Okay, or in any part of Bhubaneswar also, you have to take category 3 as the category. The last category is here, category 4. The terrain with numerous large, high closely spaced obstructions. The equivalent urban pressure is 2.0 meter. This category present large city centers, generally with obstructions above to 25 meter and well-developed industrial complexes. Okay, so for these, I think the Bombay, Pune, Bengaluru, where closely spaced tall buildings are there, that can become as category 4. I think in Calcutta also may not become under category 4 all the parts. Some new parts where tall residential complexes are there, that portion can become as category 4. Otherwise, most of the Calcutta also comes under category 3 only, like Bhubaneswar. Okay, that is one part is category 4, K2, and second part is your height. Variation of wind speed with height in different terrains. So for that, table 2. Table 2 gives multiplying factors by which basic wind speed including figure 1 shall be multiplied to obtain the wind speed at different heights. Okay. Again, I'm telling when the height of the building is less than 10 meter, we have to consider the height for 10 meter. Okay. So what are the factors is K2? For these, you have to calculate first terrain category. Terrain category 1, 2, 3, 4, and then you have to calculate the height of a building, the total height. For our truss, there are two heights. One is the height of the go down, and then height of the truss. So for first 6 meters, you have taken as, say, for my case, first 6 meters you have taken as the height of the go down, that is 6 meter, plus 1.5 meter for the height of the truss. So total height will be 6 plus 1.5, that is 7.5. But since 10.5 is 7.5 is not here, that's why we take the height for the 10 meters. Okay. Now, if you see these things, as the terrain category increases, the values are decreasing. Why is like that? Terrain category 1, 1.05, category 2, 1, category 3.91, category 4, 0.8. So why it is decreasing with the increasing of terrain category? Same thing. As the categories are increasing, that means your velocity will be wind speed are getting decreased. You are feeling less wind than that. Though it is the same area, based on the area you are getting the basic wind speed, and because of these your surroundings, you will get much lesser one as you go on the categories. That is why the values also decrease accordingly. 1.0 means 5% extra than basic wind speed because you are feeling huge wind speed with gust. And category 2, as I told, VB is taken from category 2 only, that's why it's 1. Then category 3, it is closely spaced, so wind speed will be much lesser than the category 2, that's why it is 0.91. And for category 4, it's very closely, at most there is no wind. Very little wind we will find, that's why it is 0.8, 20% decrease of the basic wind speed. Okay. And as you go the height, see, more is the height, more is your factor. But see, after 250-meter height, these are constant. There is no change in the wind speed because then after that it is become stagnant. There is no gust or there is no turbulence beyond that one. Okay. So for intermediate values of height set in a given terrain category, use linear interpolation. That means if you want to find 12.5 or 12 meters, then you have to interpolate between values of 10 and values of 15. That's it. Okay. So any doubt about category 2, K2?